The reason I think it's popular is that basically shipping code to a server is really hard. It should not be hard. We have become experts at working around that difficulty as a profession, but really it shouldn't be that hard. It shouldn't take that much expertise, right? Especially if you compare it to getting code into a mobile device. The level of tooling that is available to everyone out of the box is just much, still needs a lot of work, let's put it that way. And so you guys know all this, but also I'll keep it short. But once upon a time, the typical stack looked like this: the server, the framework, the stack, and that was it, right? The server with a capital S. And now it looks more like this, right? You've got a software stack that is much more distributed and complex and diverse. It's service-oriented. It's loosely coupled components, different languages, different frameworks that might change over time. And that software stack needs to run on a hardware infrastructure that itself is becoming larger and more complex and more diverse, right? It starts with your laptop, your colleague's laptop, the test machine, QA, your in-house cluster, the public cloud cluster, cross-cloud deployment. Increasingly, you've got software companies that offer a SaaS service, and then their customers say, hey, I would like an appliance of that, right? Can you ship that as an appliance? By the way, I run this or that infrastructure setup. And so you have a more complex software stack that needs to run on a more complex and diverse hardware infrastructure. And the result is what I call the matrix from hell, or the matrix of doom, which if you're in the profession of writing or shipping software, you're familiar with it in one way or the other. You've got every software component in your stack multiplied by every place where it might need to run one day. And your job is basically to make sure that every intersection of that matrix somehow works, right? Tests pass this in the same way on every intersection. If the tests pass on my laptop, then hopefully the tests pass in production, and dealing with those possible differences, right? So the typical scenario where that doesn't happen is where you're developing on your laptop and it's a certain version of Python, a certain version of the libc. It's a certain distribution, and then it works on your machine, and then you ship it to production, and it's not Ubuntu, it's Red Hat or CentOS, right? It's not Python 3, it's Python 2.6, et cetera, multiplied by all these different rows and columns. So in a nutshell, what we're trying to do with Docker is contribute to solving this problem. And one way you can think about the problem and look for possible solutions is finding a group of people who've had that problem in the past and solved it, right? So the analogy we like to use is the shipping industry. If you need to ship stuff somewhere in the world, for centuries the problem was basically, I need to ship coffee beans. I need to get them on the other side of the world. It is my problem how those goods are handled every step of the way, right? What kind of truck is going to be used? Is the staff trained to handle those kinds of bags in Rotterdam, et cetera, et cetera? And so the process of shipping my stuff is very tightly coupled to my stuff, right? Which means that every single provider of goods has to have an expert in-house and has to map out routes and think about plan B and have all that knowledge and infrastructure in-house. And so it makes for a very brittle and expensive and unreliable process. And of course, you can represent that by the same matrix from hell, right? Every possible goods to ship multiplied by every possible way to ship goods. Same problem, except they solved it, right? They came up with this. They came up with the shipping container. They all agreed on a box. They agreed on the size, the weight, the dimensions, all the dimensions, how the doors worked, where the locks are, where the ID label is, and then infrastructure providers standardize on that, and people shipping goods standardize on that too. And so now all of a sudden you get separation of concerns, right? I'm shipping coffee beans. Now my problem is simply to load my goods into this box, seal it, and once it's sealed, it's no longer my problem. I can hand it to a wide variety of infrastructure providers. I can organize in such a way that later new infrastructure providers or new infrastructure tools can be added. I don't have to repackage my coffee beans just because we're not going to go through Rotterdam anymore. And conversely, if I'm developing infrastructure, right, I'm managing shipping routes or I'm building trucks or boats, I can standardize on that and focus on a differentiation, right? Faster boats, cheaper, better organized facilities, et cetera. So separation of concerns brought efficiency, automation, and really that changed the world economy, right? Because it's so much cheaper and more reliable to ship things. We could probably point to 15 examples in this room of things that wouldn't exist, or things we wouldn't be wearing or using if the shipping container didn't exist. So the goal really is to try and do the same thing for software, right? Because I think it's embarrassing, personally, that on average, it'll take more time and energy to get a distributed system, a collection of software to move from one data center to the next than it is to ship physical goods from one side of the planet to the other. I think we can do better than that collectively. It's software, right? So that's what we're trying to do or contribute to. And the way we're doing it is we're trying to define a standard format that is simple enough and sturdy enough that a critical mass of people can agree to use it and integrate with it. And so really the metaphor is that, if you're a developer, those are the goods, or that's the software, the bits are there. Docker gives you a standard way to pack that into a box with standard properties, and then you can hand that box to tool makers, ops teams, infrastructure providers, and they know how to handle the box, and they will handle the box in their own particular way, while you know exactly what's going to happen in the end, right? You know how things are organized inside. So the developer worries about inside the box, infrastructure worries about outside the box, and then things are interoperable, repeatable, and ultimately they're cheaper and more reliable.